Alrighty, I'm going to go ahead and start this video off like we did in the last one, show you guys the roadmap. I'm going to be continuously updating this roadmap as we go along, and I've changed the formatting just a little bit. So as you see right here, we have our cleanup section, our lobby system section, deployment, and game loop server simulation section. Those are kind of discrete sections within what I want to cover in the rest of the chapter. And then underneath that, we will have individual bullet items for either particular videos in blue, or just a collection of the individual things that we're going to be talking about for the rest of that section. So the blue text references a video that I've already kind of stubbed out and decided what I want to talk about. So in that case, what we have right here is, for this video, we are going to first be creating a extension method on the enum type, and we'll talk about that shortly. And then we're going to talk about, or we're going to create our API interface between the server and the client dealing with the lobby system. So we're going to create all of our DTOs, or data transmission objects, and we're going to create the methods on our component interfaces that are going to be used to communicate between the server and the client to say, you know, here's a lobby that's been created, or create a lobby and whatever. And so we're going to stub out those interfaces. So I guess let's go ahead and get started. The first thing I'm going to do is we are going to create an extension method on enums. And basically the reason for that is we are going to be using flags a lot, where what I mean by flags is we'll have an enum type and we'll set individual bits on those objects, and we'll kind of use it as a bit mask so that we can flag certain things. And we're going to need that in this video. The problem is the syntax for performing those checks is a little bit gross. And fortunately, in .NET 4 and above, there's a built-in method that will do that for us. But unfortunately, that's, well, for .NET 4 and above. So we're not going to be able to use that in our base code that's shared with Unity, because we're running on .NET 3.5 that does not have that method. So basically what I did is I went out and I decompiled the logic for the .NET 4 version, and I'm just going to reuse that same implementation here. There's a couple other implementations you can see online that involve things like generic type specifications and dynamically generating methods and all that stuff. I just think that that's a little bit too much of overhead and complexity for this particular case, so we're going to keep this really simple. So let's go ahead and create that method real fast. I'm going to go over to base and extensions, and I'm going to create a new class here, and I'm going to call this enum extensions. And enum extensions will have to be static because we're adding an extension method to it. All extension methods have to be in a class that's marked as static. And I'm going to say public static bool contains flag, and it's going to be a generic method that takes in a tenum type. And I'm going to say this tenum that, followed by tenum flag. And I'm going to add some generic type constraints. I'm going to say where tenum is a struct, an iConvertible, that's going to result in pulling in system at the top, an iComparable, and an iFormatable. So let's talk about the signature real fast. Unfortunately, well, basically, first of all, enums are their own type. So when you declare an enum, something like public enum flags, that you're actually making a type. There is a base enum type, but all enums are their own class. So to create a signature, a method signature that accepts a particular object, obviously we have to have it match that type. But I don't want to say something like this object that, because first of all, this will add the contains method flag to all objects, and second of all, that'll result in boxing, which I don't want. So I make this generic so that there's no boxing involved. So when we pass in an enum, which is a value type, it gets copied by value and doesn't get boxed into an object and copied by reference. So it's a performance thing. Now, also, it's a type safety thing, because we're able to say, okay, so whatever enum that we invoke this method on, the only thing that we can pass into flag is going to be a member of that enum. In addition, for my generic type constraints, you might be wondering what's going on here. So I could, you might think, well, you could say where tenum is an enum, right? Or a system.enum. But as you see by the little red squigglies, you can't do that. For generic type constraints, you can read that error message right there, you can't use array, delegate, enum, or value type, or object as a type constraint. So what I did instead was I went ahead and listed as many of the things that will make this method only apply to enums. So an enum is a struct. System.enum is a value type, so it's a struct, and then it implements iConvertible, iComparable, and iFormatable. So this kind of really constrains this method to only be used on enums, despite the fact we can't add a generic type constraint that's specific to enums, which is unfortunate. I don't really understand the reasoning behind that, but I'm sure there is a reason somewhere. All right, so by the method signature alone, we know that we're getting a struct, and it's probably an enum. And we know that both parameters are the same type. So that's a lot that that's a lot of safety that the type system gives us. But again, we're not entirely certain that what's passed in is an enum. So what I'm going to do here is I'm going to say if not type of tenum dot is enum, then throw new argument exception. And I'm going to say something like, I'm going to make this a templated string here. I'll say type of tenum dot name is not an enum, and I'll pass in that as the name of that as the parameter name there. So at this point we're certain of three things. That is the same type as flag, and both of them are an enum type. So what I'm going to do here is to be able to check a flag. So let's say we have a flags here, and I have like 1 equals 1, 2 equals 2, 3 equals 4, because of course all of these values must be powers of 2 in order to set the correct bit. What we do is we do a bitwise AND between this enum and the flag, and then check to see if it's equivalent to the flag. So basically, if our enum is 1, 0, 0, 0, and our flag, the flag we want to check, let's say we want to check if it has 1 there, so we would do 1, 1, 0, 0, for example, or sorry, 1, 0, 0. What we'd want to do is we'd want to AND them, and ANDing them would result in 1, 0, 0, and then we want to make sure that it is the same value, or same bitwise value as this one. But unfortunately, there's a problem here, and the problem is that enums have backing types, and the problem is in the CLR level, these enums are represented as these backing types, not as their own enum type. And so we need to be able to do bitwise operations on a variable that we don't know what backing type it is. So there are runtime solutions for me to check to see, oh, is this a byte, is this a long, is this an int, and so on and so on. But I think that performance-wise, that would be problematic. So instead what I'm going to do is I'm going to convert both the enum passed in and the flag passed in into the most permissive type, or the base type, that the value type that has the most bytes available, so that it covers the widest cases. So I'm going to say var that bytes equals convert dot to uint64. So this is a ulong, or an uint64, and pass in that. Then I'll say flag bytes equals convert to uint64, and we'll say flag. So now we have two uint64s, which it's unfortunate that we have to do this conversion, especially on 32-bit systems, but I do believe that the performance of this will be still fairly good here compared to other solutions that require us to, at runtime, check what type they are. And then I'm going to simply say if that, and this is a bitwise and, this is not a logical and, so there's only one ampersand. If that and flag bytes equals flag. Whoops, that bytes. I have the dumb. And this is flag bytes. I really have the dumb. So now that we have that going, we now have a contains flag. So that was a lot of exposition just to write a small method, but it's important to understand what's going on here and why I decided to do it this way, mainly for performance reasons. Anyway, let's go ahead and move on and jump into our base components and start talking about our systems. So let's clean this up real fast. So we have this character select system. I'm going to go ahead and just delete that. The character select system was there just for showing you guys an example of a system. I don't really care too much about that. And then for our login system, let's go ahead and just complete this real fast, because this is actually pretty straightforward. So I'm going to nuke pretty much everything out of the iLogin system server and the iLogin system client. Before we nuke that, I am going to go over here onto this folder name, and I'm going to change it. I'm going to call this systems.master. And then I'm going to change the namespace to systems.master. Now, I'm doing this because we want to have our master server systems in a different namespace than our region server systems, because that way similarly named systems shared between the servers are not going to get cluttered into the same folder. So our ilogin system server is going to have 3 methods, and they're all going to be deferred. So we're going to have a deferred of user details, which we don't have that class made yet. We'll be making that in a moment. Login and string token. So this is a straight up login. So when the client tells the server, I want to log in with the token that was established from the launcher, this is the method that's going to call. Then we're also going to have a deferred of user details, and this is going to be called debug login, and it's going to accept a user ID. So the debug login is only for in development servers where we don't want to be presented with a username and password. We just want to click on the user that we want to log in as, and that's very useful for debugging and testing. And then we'll also have a deferred join main lobby. So basically, the way that the way I implemented the system was that the first thing the client did was it logged in, it retrieved its user details, then it loads up the lobby UI as a different scene in Unity. And once it's done loading that, then it'll tell the ilogin system server, "Hey, I'm done loading. Let's join the main lobby." So for the ilogin system client, we're going to have void debug set available players, which will be an array of user details users. So this method is used by the server to tell the client in a debug scenario what users are available, so that we can present the person testing with a list of users that they can log in as. But anyway, so we have that all done. Let's go ahead and create our user details class. So I'm going to say public class user details, and user details is going to inherit from iCustomSerializer. So I'll go ahead and do that, and then I'll hit Alt Enter, 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 and that'll go ahead and stub out our save and load. So our user details DTO, or data transmission object, is going to do its own custom serialization. It's not a built-in thing. When we write the actual serialization that will use generated code later in the series, of course this won't be necessary, but for now we have to write custom serializers whenever we have an object that isn't a base type. So user is going to have a public int ID with a get and a set, a public string username with a get and a set, and a public hash set, of string called roles, and then that'll be get and set. So then I'm going to go ahead and generate 2 constructors. I'll generate one constructor that's going to accept all 3 of these as parameters, but then because this is being used with our serialization engine, our simple serializer, we also have to generate a default constructor, so no parameters and doesn't set anything. Now for our save, we'll simply say writer write ID, writer write username, and then for our roles, I'm going to say writer.write. Let's see here. We could cast a byte here, so I'm going to cast our roles length to a byte. I'll do roles.count. Then I'll say for each var role in roles, writer.write role. I could have also used the simple serializer to serialize the hash set because it implements IEnumerable and our serializer supports IEnumerables. But in this case, I went ahead and I'm just serializing it as manually, primarily so I can shave off a couple bytes by converting the int32 count into a byte. We're never going to have more than 255 roles, and if we do, well, that would just be really weird. All right, for our load, we're simply going to do ID equals reader read int32. Our username will be reader read string, and then I'm going to say var role count equals reader read byte, and I'll say for var I equals 0, I smaller than role count, I plus plus, and for here I'm going to say roles.add. Yes, I know there's a bug here. I'll fix that in a second. Reader read string. So maybe you want to pause the video if you haven't caught the bug already, and try to figure out why this code's going to blow up. Anyway, the problem is I completely forgot to actually instantiate my roles hash set. So I'm going to do that in the default constructor. I'm simply going to say roles equals new hash set of string. So that way I don't have to worry about it ever not being instantiated. Unless, of course, someone passed in a null hash set into this constructor, but that should never happen. I guess the last thing that I want to do is I want to create a toString method. So I'm going to create a toString method here. And the toString method is simply going to return, and I'll use template strings here, player colon username, or how about player colon ID comma username. So the way I like doing my toStrings for this is using a kind of Lispy syntax where I wrap everything in the toString with parentheses, and then I just do the name of the object followed by a colon, or the, in this case, not necessarily the name of the object, but the thing that it represents, then its properties. And the reason I do that is because it makes nesting toStrings very, very simple and the output very readable. So for example, if username was a more complex object that I wrote myself, it would expand out to be something else. So that's how I like doing that. Anyway, so that is our login system. Pretty straightforward. Not a whole lot to talk about. So let's go ahead and move on to our main lobby system. Now, our main lobby system, let's go ahead and create that file, main lobby system, and let's go ahead and create the interfaces. So we're going to have a public interface iMain lobby system server, followed by a public interface iMain lobby system client. And both of these will have our component interface attribute. And the main lobby system is what happens when we join the game, after we log in. So we get a list of lobbies, a chat room, and an ability to create a new lobby or join an existing lobby. So, so let's just do what we did before. I'm going to write all the methods first, and then we'll write the DTOs that we're going to need. This will be a little bit more involved than the last one. So first of all, we're going to have a deferred of type lobby details called create lobby. So when we create a lobby, we don't pass any parameters in, and we get back a lobby details object. Then I'm going to go ahead and create a deferred of lobby details called join lobby, and for that we'll pass an int lobby ID, and then we'll do a deferred of, or just a normal deferred, abandon current game, and then we'll have a void send chat message string message. So we have our create lobby, join lobby, abandon current game, send chat message. All of these should be fairly straightforward as to what they do, except for abandon current game. So if you are if you're in a game and you shut off your Unity client and then you join again, I don't want people to be able to create a new game while you're already in one. But I want to be able to have the user be able to abandon that game from within the main UI. So when they log in, they see, oh, I'm already in a game, I can't join a lobby, I can't create a lobby, but I can abandon the current game I'm in. So that's what that method is for. Send chat message is obviously sending a chat message. Okay, so this will be a little bit involved. We're going to have void on player enter. Or how about entered? Main lobby player details player. We'll have a void on player updated. Main lobby player details player. We'll have a void on player left, int player ID. And then we need the same sort of thing for our lobbies. So we'll have on lobby created, lobby details lobby, void on lobby updated, lobby details lobby, and on lobby destroyed. And this will just be int lobby ID. Then we'll also have an on already in game, which will take in a int game ID followed by a Photon server connection server, and then let's just leave it as it is right here. Or maybe, you know what, I'll go ahead and do that. I'll do a string level name. So the idea here is the on already in game will be sent from the server to the client, well, if they're already in a game. And what we need is we need the ID of the game, we need the game server that the game is running on, and then we need the game parameters, in this case just string level name. In the future, I'll be switching over from using string level name to using an object that represents the game parameters. Things like what level are they using, what sort of additional parameters were set, if the individual maps have parameters, like maybe a time limit or something like that, and then that would be sent to the client as well. But, okay, so then we'll go ahead and do void on chat. Whoa, that's not right. Void on chat message received. And on chat message received, we'll get a int, let's do a sender player ID. And it'll also take in a message. And it'll also take in a date time, which will import system. And we'll call that received at UTC. So we're going to be sending all of our dates and times in UTC or GMT for obvious reasons. And then we'll have, actually, I'm going to take, I think I'm going to take this, I'm going to drop it down here, and then I'll say void on game abandoned. Or on current game abandoned. And this will take in game ID. So this message will be sent from the server to the client saying, hey, you clicked the on abandoned button, so you are now abandoned. Okay, so we have lobby details and main lobby player details and Photon server connection to make. So these DTOs are going to be interesting. We're going to be using them across the entire project on both the server and the client to store information about what people are doing, what heroes or what teams are being selected and all that stuff. But what's going to make them interesting, though, is you'll notice like my on-player updated. My on-player updated takes in the main lobby player details, or my on-lobby updated and so on, takes in that entire DTO. But I don't want to have to serialize and send every single bit of information that might have changed. So for these DTOs, I'm going to be using change tracking inside of them to have only send the information that got changed when that DTO is updated. So that'll save on bandwidth and performance. So let's go ahead and create those. I'm going to create those outside of the systems master in the Buzz MMO base components. So I'll go ahead and create a new class, and I'll create a lobby details. And my lobby details, we're going to have a couple interesting things here. We're going to be using an enum to track the status of the lobby. So to do that, I'm going to create another type here. I'm going to create an enum called lobby status. And the lobby status will be active and starting game. So active means that people can join and change their things and all that fun stuff. Starting game means the game is starting. Well, I don't know, pretty straightforward. So the idea is it starts off in active. It can then, from that point, either be destroyed or the game started. It'll go to starting game, and then from that point, it'll either go back to active if there is an error, or it'll get destroyed, in which case it'll disappear out of the list. So that's our lobby status. Now let's jump back into lobby details. I'm going to do this in a weird sort of way here. I'm going to start off by creating a public enum fields. Now, the fields is going to inherit or have a backing type of byte, and I'm going to give it the flags attribute. Now, the flags attribute really only impacts how this enum is represented when we do a .toString call in it. But I like always adding the flags attribute to a enum that I expect to use it as a flag, or as flags. And for our flags, we're going to, or a fields flag, we're going to put in all the fields. So in this case, we'll say name equals 1. Player count equals 2, status equals 4. Remember, we're doing base 2, or not base 2, we're doing powers of 2. If we don't do that for each one of these members, then the flags will not work right, because again, we're setting individual bits on a byte, so they need to represent each bit, or where each bit is positioned. We'll have owner ID equals 8, so that's the owner of the lobby, and we'll have, actually I think that's it. So we have these fields. Now, the way I'm going to do this is going to be kind of interesting. I'm going to do a public, I'll start off with saying a public int ID. And then I'm going to say public fields changed. Now, this changed property is, we want a private set on this guy. The change property is used to show this DTO, what are the fields that were set? Now, ID will always be set. That should be pretty obvious because when we pass in the lobby details, the on lobby created and updated, we don't get an ID. So the ID will always be set. The fields will always be set as well. But then the rest of the fields will only be set if the changed field has, the changed flags has that marked as being set. So I'm going to just really quickly stub out our properties as automatic properties at first. So I'm going to say public string name, public get, public set, public int player count, public get, public set, public lobby status, public get, public set, and public int owner ID, public get, public set. Then what I'm going to do is I'm going to go ahead and convert all of these into properties with backing types. Now, I'm not sure if Visual Studio 2015 has a built-in refactoring for this. ReSharper does, but you might want to look to see if Visual Studio 2015 has a way to do this automatically, but I'm going to use ReSharper. So I'm going to go ahead and use my keyboard cursor and select this property. I'm going to hit Alt-Enter, and then I'm going to say to property with backing field, and then hit Enter. I also want my fields to go after this enum, so I'll go ahead and do that as well. Now, all I'm going to do for all these fields is I'm going to change their setter. And the setter is simply going to say changed or equals flags field, followed by the name. Make sure to get your semi, and then I also want this to be on the same line. So this is what we're going to do to all of our properties. When we set them, the changed field gets updated. So we'll do that here, to property with backing field. We'll come over here and say changed or, oops, come on, you can do it, Visual Studio. Changed or equals fields player count. And then for status, we're going to go ahead and say to property with backing field, and then we're going to say changed or equals fields status. And then for owner ID, we're going to do, well, the exact same thing. Changed equal or equals fields.owner ID. Okay, so unfortunately that's a lot of code. I'm thinking about wanting to come up with a better way to do this. I'm sure there is a better way to do this, but for right now we're just going to have to write out a little bit of code to get this to work. When I come up with a better way to do it, we'll refactor this, but I really don't want to waste any more time getting up to our ability to actually run the game. Anyway, let's go ahead and generate a constructor, and the constructor is going to set all of these parameters except for changed. Now, I am going to change this to using the properties instead of the fields. And the reason for that, I also want the ID to be the first thing. ID followed by name, player count, status, owner ID. Okay, good. ID should always be first when you write a constructor like this. Anyway, so I'm using the properties on purpose so that the changed field gets properly updated. So when we use this constructor, every single item will be marked as changed. Then I'm also going to create a constructor that's going to be default. And obviously this is because we need to be able to instantiate this from our simple serializer. So anyway, speaking of our simple serializer, let's go ahead and write our load and save methods. So I'm going to come up here to the top and say iCustomSerializer. I'm going to hit Alt-Enter, Enter. And so we'll get our save method and our load method. So our save method is simply going to say writer write, and we're going to pass in byte changed. Well, let's do ID first. Writer write ID. Then I'm going to say writer write, cast a byte changed. Then I'm going to say if changed contains, remember that contains flag method we wrote earlier? If changed contains flag fields name, writer write name. Then I'm going to copy and paste this 3 times, and we'll do, after name, we will do the next one on the list, which is player count, and we'll do writer write player count. And then after that, we're going to do status. And for status, I'm going to convert this into a byte and say status. Actually, let me make sure lobby status uses... Oh, come on. Come on, Visual Studio. What are you doing to me? Well, I'll go ahead and pause the video while... Oh, ah! And Visual Studio crashed. All right, I'll be right back. All right, not entirely sure what happened there. It didn't even give me a error or warning or anything like that. It just decided to die. Anyway, so we have our status. I forgot what I was talking about. So status is there. Oh yeah, I was checking to see if this is a byte, and it should be. Actually, you know what? I think I'm going to make this a flags as well. And the reason is maybe maybe in the future we might want to put additional like things that lobby status can simultaneously do. I don't see lobby status ever getting more than 8 elements, which would be the limit for using a flags with a backing type of byte. Anyway, that change is entirely inconsequential at this moment. So let's go ahead and come over here and let's do our owner ID, which is our last field. Now for our load, we just do the opposite. So ID equals readInt 32, and we'll say var, or we'll say changed equals fields, cast of fields, and reader read byte. And then the same logic. If changed contains flag fields.name, then name equals reader.read string. Now, I really hate writing tedious code, but in this case, like I said, I could certainly have gone out and written something to make this a little bit more bearable. I would like to at some point, but at this point, this will have to do. Okay. So now let's go ahead and do our toString method. So I'm simply going to say overloading operators, toString, and I'm going to return a template string, and simply going to be lobby followed by ID. Or how did I do that? Where is my... What did I do there? I already forgot. In this case, I just did ID, comma, username. In this case, I'm going to do ID, comma, followed by our lobby name. And maybe player count is player count. I mean, really, you can put however much and however little information you want here, but we'll just do ID and name and player count for debugging purposes. Okay, so that's our lobby details. Now let's hop back into our lobby main lobby system and talk about our main lobby player details. So our main lobby player details is basically, just going to be a. Actually, we can just reuse user. I'm just going to reuse user details here. I'm not going to worry about that. And the reason for that is once we actually get to listing the players inside of a lobby, then we'll have more fields to work on. But for now, I'm just going to use straight up user details. Let's do our Photon server connection. I'm going to come over here, create a new class, and create a Photon server connection class. Or actually, I'm not going to put that here. I'm going to put that in our BuzzMMO base class project right here. So I'll create a new class called Photon Server Connection. I feel that this would be useful in a lot of different scenarios, so I'll keep that there. We'll simply do a public string address, public get. We can do public get private set or public get public set. Doesn't really matter here. It's just a DTO. And then we'll do application name. Maybe I'll do private set here. And because these should never change. Then I'm going to go ahead and create our constructor, our main constructor, and our custom constructor. And then I'm going to make this inherit or implement iCustom serializer, which will simply, for our save, simply say writer write address and writer write application name. For our load, address equals reader read string, and our application name equals reader read string. We'll go ahead and do our toString method, which we'll be using template strings. And I'm simply going to say Photon server. And it's simply going to be... Did I put that colon? I want to be consistent here. Did I put that colon? I did put that colon there. Okay. Address followed by application name. Terminate that. And I do preemptively want to do something here as well. I'm going to go ahead and mark this constructor as our JSON constructor. So the reason I'm doing that is I want to be able to serialize this in JSON because we're going to be using it in our configuration objects. And when JSON.NET runs into a class with multiple constructors, it needs to be told which constructor to use. And in this case, I'm marking this one as its default constructor. So yes, that's our Photon server connection. That should actually wrap up our main lobby system, and it does, because remember, we don't have to import anything because we're in a sub namespace here out of base. So now let's move on to our last system that our main master server is going to have for now. Obviously, we'll be making more systems in our main server, things like changing your account, updating your profile, and fun stuff like that. But for now, the only last system we're going to need is going to be game lobby system. Is that what I want to call it? I think so. Game lobby system. So we'll do a public interface iGame lobby system server, and we'll do a public interface iGame lobby system client. And we're just going to do the same thing we did before. We'll write our methods first and then our DTOs. So we're going to say deferred destroy lobby, deferred begin game, and then we'll also put in deferred change team, and this will take in a game team and a deferred change hero game hero. Then for our client, we're going to have void on lobby. Did I do changed or updated in our main lobby system? I really want to keep the language consistent across all of our interfaces. I used updated. So on lobby updated, and this will take in a lobby details. So if let's say a user creates a lobby and then leaves the lobby, if they do that, then the lobby will get a new owner, and we'll have to update that. In fact, we also have to do a deferred leave lobby up here as well. So make sure you add that as well. Totally forgot about that. Next up, we have void on player entered, which will be a game lobby player details player. Void on player updated, game lobby player details player, and a on player left, which will just be int player ID. Then we're going to have a void on game started, which will be int game ID, Photon server connection server, and string level name. Again, we're probably going to take this and put it into its own class that can represent different options that the level has. We'll have a void let's say on game failed to start string error. So if there was an error starting the game, we want to be able to tell the users about it. Okay, so we need game team, game hero, game lobby player details. So the game team, the game hero, I think I'm going to leave in base components for now. So let's go ahead and create two enums, game team, and for game team, it's simply going to be none, humans, and Lethians. I hope I spelled that right. Next up, we'll do game hero. And the game hero, we're going to be changing this enum later, but for now we'll do none tank damage support. So we'll have individual like names here or something at a later time. But for now, they're more like classes than heroes. Okay, so inside of this, we now have our team and our heroes. Now let's do our game player lobby details. So that's not going to be fun, but let's go ahead and get it over with. So game lobby player details. It's going to be an iCustom serializer. And we're going to have a public enum fields that has a name is lobby owner team hero. We'll have a public int ID, get public set. We'll have a public fields changed. And before I forget, let's flagify this. Make it a backing type of byte. Name will be 1, that'll be 2, that'll be 4, and that'll be 8. And then we'll have a public bool is lobby owner. Actually, you can infer lobby owner from the lobby configuration. Let's just go ahead and just do name, team, and heroes. So we'll do public string name. Public game team, public game hero, and then let's go ahead and do to property with backing field. Make sure you move that up. I always like my types being right there. And then we'll do changed or equals. Again, terribly repetitive, boring code that will one day be not repetitive and boring. But that day is not today. Don't worry. This is the only other one that I've implemented so far that we will need for quite a while. That's another reason why I didn't want to spend time building an easier method of doing this, because we only need to do this a couple times. Okay, so we have our name, team, and hero, and blah blah blah. Let's go ahead and create our constructor name, team, hero, ID, and let's move our ID to the top. Let's change these to accessing the properties and not the fields directly. There is one more thing I want to do to both this game lobby details and the other one, so we'll do that in a moment here. Our save will always write out our ID first, and then we'll write cast to byte our changed, and then if changed contains flag fields name, then writer write name, and then we'll do fields hero. Here's the second. No, team is the second one. Let's go ahead and reflect that there as well. Writer write cast to byte team. That was an unintentional rhyme. And then we'll come over here and we'll do hero blah 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 blah. Okay. So for load, we will first say ID, not OD. Don't want to do that. ID equals reader read in 32. Changed equals cast back to fields reader read byte. Another cool thing about doing this change tracking this way is because we're going to be using Unity's new UI system, which is not immediate mode, meaning we have to actually, when something changes, we have to go out and edit that. By doing the change tracking this way, we could do something like display an animation when just the name changes or something like that without having to do an equality check on what the old parameter was. So I kind of like that. So then we'll say if changed contains flag fields name, name equals reader read string, copy and paste that. If it contains team, then team equals cast to game team, reader read byte, copy and paste that, and we'll do the same for hero. All right. So that is our game lobby player details. Of course, we do want to override the toString. So we'll do player ID name and game team and game hero, and we'll leave it at that. It doesn't like this because it was just team and hero. Those are types, not properties. Okay, so let's move back into our system. And everything seems to be working. So the last thing I want to do before we make this compile is I want to add one more method. So I want to come up here. After the constructor, I want to say public void reset. And it's simply going to say changed equals 0. Or how about reset change? And the reason for this is we're going to be reusing these objects on the server and sending them off. And before I make a bunch of changes to one of these objects, I want to reset their changed flags so that when we set new properties on them, it picks up on what changed, and then we can just shove that right into the client. So it saves on memory and all that fun stuff. So I'm also going to do the same thing to our systems, or whoops, our lobby details. So I'm going to come down here, and after the constructors, I'll say reset change. All right, last thing to do is to make sure everything compiles. Let's go ahead and hit F6 and get a nice list of errors to deal with. And see how badly everything broke. Okay, so mostly has to do with our iLogin, or entirely has to do with our iLogin system server. So let's go ahead and collapse this. So for our client console systems, let's go ahead and come up here, hit Alt-Enter, and say reference BuzzMMO base components, and reference these types. It doesn't seem like it wants to reference that. So let's hump over here and make sure that base components is being referenced, and it is. Let's try to do that. Let's go ahead and remove all of its implementation. And okay, so here we are in BuzzMMO master. So for this, I'm going to remove its entire implementation. Remember, this was just there for testing. And I'm going to hit Alt-Enter and implement all of these methods. But I'm not going to actually write any implementation in them. I'll just leave it throwing an exception. All right, so let's hit F6. This is so this is complaining in our BuzzMMO server master automap assembly of ilogin system server. We just need to import that new namespace. Remember how we changed the namespace? Hit F6 again, and I'm ignoring this project for now. Well, it seems like this is the only project that's not building. Why is this not building? ilogin system server, reference and import. Oh, we have to implement the missing methods, and then hit F6, and build succeeded. So I'm not entirely sure why BuzzMMO client console systems is throwing this error. This actually wraps up the video, because it is compiling, but it's just not, it's throwing this nasty error. That looks like a resharper error. So if you guys aren't getting this error, this wraps up this video, and I hope to see you guys in the next one. But if you are getting this error, I'm going to try to fix it by coming over here to Resharper, going to Tools, and jumping over to Options. I always forget where they moved this thing. It's like in General, maybe? Yes, Clear Caches. And then I'll say caches will be cleared after Visual Studio restart. So I'll save this out. I'll close Visual Studio. And oops, I did not mean to run Visual Studio as a normal user. I meant to run it as an administrator. So, fun stuff. So, yeah, let's close this one. And let's open this one. And we're back. Crossing my fingers, and we're still getting squigglies. So something is really not right. Another potential issue, I'm going to go ahead and unload this project entirely. Another potential issue is that it's hard-coding the hint path to the reference, which would result in it not building. So I don't think it's that, but it's the only other thing that I've seen that will cause this. So let's go ahead and see how the reference is created. See if it's a project reference or if it's a hard-coded file reference to the artifact directory of that project, which will always cause issues. No, there is no hint path. It is referencing the CS project directly. So let's go ahead and reload that and come up here. Oh, it's working now. Okay. That's cool. So we're in the green now. All right. Well, unfortunately, this video lasted a little longer than I expected to, but we now have the complete API surface done for our component. So in the next video, we're going to move on to the client, and we're going to write code against all of these interfaces that we created. And we're going to do so without a connection to the server. So we're going to write our client completely independently of our server, get that all working, and then we'll hook this up to the server and write the server code. So we'll see you guys in the next video.